To do this morning, because I know there was a lot of questions and stuff coming in and rolling through and all that, is that I started writing up solutions for some of the more complex ones on the windows from yesterday. I think up there on the window I have 4, 5, 6, and 7. I think I have 4, 5, 6, and 7 up there. Number 8, go the other direction.
Oh, that's what I did.
Go the other direction. When I was looking through these real fast again yesterday, just saying, hey, I'm trying to figure out which ones would be good that can help you guys do some more verify ones. I think that number 6 was the most complex of all of them, and number 8 you just had to go backwards. Okay. So if we hold off on 6 and realize that all you had to do on number 8 was go backwards, what do you want to look at before we go into the equation with? Yes, Andy? Fine.
We didn't turn in the last 2 days, did we?
No, I wanted you guys to hold on to a lot of these things because the more you see of it, of the tricks of how things interrelate, the better you're going to be tomorrow.
Right, because all
It's all kind of the same thing when it starts boiling it down. When you see something like this, and it's not of the type that you could do the conjugate. Conjugates more often than not happen when you've got just an addition problem in the denominator and just a single part up top. Here you've got addition in both numerator and denominator. When you see something like that, a lot of times your best bet is to go common denominator. Oh, I thought it was right there. Is it? No, that's not it. That's another one. Your best bet is to just go right for common denominator. So split it into a complex fraction. What? Oh, I thought you were looking at like you didn't know what a complex fraction was. Like I was really, really crazy.
So I got 5 on.
Okay. They're very similar. They're very, very similar. So you start splitting it up. You get 1 plus 1 over cosine over sine, cosine, plus sine over 1. Work with each one of the denominators parts independently to get the common. So you get cosine, so it's cosine plus 1. Here it's cosine again, and it becomes sine plus sine times cosine. When you go from the next step is that you notice that you have sines grouped together in that lower numerator. Factor out the sine. Hi, that's okay. I didn't think you were out selling crack. Little do I know. Exactly. So at this point here, I'm just going to rewrite this as sine times 1 plus cosine all over cosine. We okay with that? Now what I'm going to do is take that lower denominator, multiply by its reciprocal. Okay? So I rewrite my first one, which was cosine plus 1, over cosine, times cosine over sine 1 plus cosine. Dun, dun, dun. Do me a favor, don't write that as sine, because it is. It's 1 over sine. Yes, ma'am. Yeah, I'm just going to 1. I didn't need to factor that whole thing. Because you're killing shorts. Check all the time. 3.
Thank you, Kelly.
3. It's cosecant to the 4th minus cotangent to the 4th. Those of you guys have heard me say this question numerous times throughout the day today. Is the first term a perfect square?
Yes.
Is the second term a perfect square? Is that a subtraction symbol?
Yeah.
It's a difference of squares. So now think about your Pythagorean identity. 1 plus cotangent squared is cosecant squared. Therefore, cosecant squared minus cotangent squared is 1. So this becomes 1. And then here, it wanted it in 2 cosecants, correct?
Yeah.
So here all I have to do is rewrite the cotangent at, so it'll be 1 plus cotangent is cosecant squared minus 1. And now you have 2 cosecant squared minus 1.
Oh, I see.
No way.
What else?
Number 4. I think I tried to do the reciprocal, like the conjugate. I think
You have to get your denominators to make that work because you're simplifying over addition. This is an example. Hey, Michael, don't do conjugate. That's why. Yeah, once you get into conjugate in this one, it just becomes a nightmare because you've got that horrible foiling in the numerator. You just wind up with some awful stuff. So when you see that and you start to get into the idea that it's just going to start to get all sorts of bad, rewrite everything as a complex. So if you go complex in this case, you wind up with cosine over 1 plus cosine over sine, which winds up being, geez, you get lost on your way or something, or what?
No, I had a French test thing.
Whatever. Sacre bleu.
What does that mean?
It's slang for like, oh my gosh, or it's the sacred sky is what it stands for, right?
Well, it's blue. It's because of the various homes was where there's certain colored blue and so it's the same blue.
I didn't know that.
I did not know that either. I thought it was like slang for like, oh my gosh.
Well, it is, but like
But the true
literal
meaning-
translation means sacred blue.
Huh. Wow. Thank you for letting me learn something new today. That. It's like, remember, Kobe CD say pie. And it's, she was mortified. She was just taking it, because she was a student teacher.
Yeah.
It was just great. It's great to harass student teachers. It's
She
fun.
goes straight to Google Translate.
Yeah. Oh, hold on. So, here you get sine. So you have cosine sine plus a cosine.
You take out the cosine.
The denominator here, you wind up with 1 over sine plus 1 over 1, so you get 1 plus sine over sine. You okay with me so far? Take out the cosine at the top. Oops, sorry, sine plus 1. Multiply by the reciprocal. So if you start to see something that the conjugate isn't working, especially if you have 2 terms in both the numerator and denominator, try to go common denominator.
Yeah, I was gonna say, so if you have like 2 terms multiplied together, like plus another terms, did you like factor it out?
Yeah, it's kind of a dead giveaway of what they're trying to get you to do. Right? Those are, like I said, those are those little subtle things you shouldn't have picked up when you go through on these. Yeah.
Cosine, sine, cosine.
The third step there,
Yeah.
how do you get sine?
Here they both share a cosine, so I factored it out.
Oh,
Plus cosine equals sine.
It's the same idea as 4x minus 4. I factored out a 4. Same idea.
So cosine sine plus cosine sine. Cosine.
What's that? Destiny, you're going to get kind of PO'd at number 7.
yeah, I mean, you can work
In this case here, notice how it's 2 terms denominator, 1 at the top. And conjugate. This is your conjugate problem.
I did it over here.
Your denominator becomes secant squared minus tangent squared. Secant squared minus tangent squared is a Pythagorean identity because 1 plus tangent squared is secant squared. Therefore, secant squared minus tangent squared is 1. And what's your numerator?
Oh, I can do that.
Wait, I don't know if I did it right.
Wait, say that again.
Secant
Can you
squared.
look at the denominator?
I did a complex bracket.
What I did there in the denominator, This is your prime example of when you should multiply out by your conjugate. When you're multiplying by a conjugate, you're just changing the shape. You're multiplying by a factor of 1. The conjugate of secant minus tangent is secant plus tangent. When you FOIL that out, it's giving you a difference of squares. So I got secant squared minus tangent squared. The trig identity for tangent squared is 1 plus tangent squared is secant squared. Therefore, 1 equals secant squared minus tangent squared.
Wait. Can you just tell me if the land of this is okay?
Did you go common denominator and try and pull it through?
I don't really know.
No, I have to do it tonight. I finished sewing my one extra stuff in. Did I tell you? It's called design making.
Oh, yeah, it is. And it's flat.
Yeah, and my other one is question all the way.
Yeah, that's perfectly fine. It's not pretty, but it works. Yeah, no, that's perfectly fine. That's perfect. That's exactly right. You did that perfectly fine, Phoebe. That's good. It's a lot harder than the way I did it, but it works. It works. But like I said, guys, there's more than one way to skin a cat. This is just one of those things that you see. What do you want now? I know, but I just felt like saying that. Like I said, number 6, I thought was the most complex of all of them.
Oh, yeah, you should have start that one.
I don't know. There's a little trick here, and if you pick up on it, you'll see it. Notice how you've got one term denominator, 2 in the top. What should you do?
1 minus times.
Split it. Split this one. When I split it, then I get. You okay with that, right?
Yeah.
Okay. Now, I'm going to rewrite this in terms of cosines. Okay? What's your common denominator?
Cosine.
Oh, now you have 2 cosine squared minus 1 in the numerator. Okay?
Wait, that's not there.
I know it's not.
Return the colors.
What did I turn cosine into? Cosine squared, excuse me. So the numerator becomes 2, 1 minus sine squared. Distribute 2 minus 2 sine squared minus 1, which is 1 minus 2 sine squared.
Oh, I see.
That's a tricky one.
How did you get cosine squared?
How to get cosine squared? When I went to the common denominator, see how the common denominator here is going to be cosine?
Oh, that one doesn't have a cosine, so, okay, there we go.
Yeah, that's how
That one's, I think of all the verifies we did, that might be one of the toughest ones because it comes out of nowhere to set that one up.
Wait, how does 2 times cosine squared minus 1 equal? Oh, wait, never mind, I got it. I got it. It's the Pythagorean.
Those are helpful to remember, aren't they?
Yeah.
Okay. Let's look at the solve equation ones.
Yeah.
I know that when I was, remember how I had talked about that there aren't that many of these to choose from in the book and all that? The one where you wind up with sine of x equals a fourth, did you guys see that one?
Yeah.
You did it perfectly fine, okay? You did it absolutely perfectly fine where you had sine of x equals 1/4. You don't have a calculator on this test, so you're not going to be able to find that value of x. That would have to be with the calculator. Now, the other part of that problem was sine of x was equal to 1. So you could have given me that one at pi over 2. Then you're fine. You did fine, okay? Remember, all I did yesterday when I was trying to find extra problems for you guys to have to do some Pythagorean work and factoring, I was just looking really fast for questions. And I didn't work that one out to get it to a fourth until later on. So if you had it equal to a fourth, you did great. okay? You're fine. Now, I'm not going to give you something on the test tomorrow that's going to end up in a 4th because you won't have your calculator, so you'll be very, all right? Yes, ma'am?
Wait, should we just clear really quick? Okay, so in the book, when,
That was the fourth one.
in the book, it only came out with these two pieces.
Okay.
And then, but when they got these
That is true.
Like, they can't do it. I wouldn't do general solutions.
I
would say
one through eight.
You're right.
Yours in the back of that. And 27, 29, 30, 37.
Yeah, it is.
Yeah.
The book was looking for
I've been trying to stick it into my dad, but I haven't
they didn't give you the solution.
Yeah, you did is right. And that's exactly what I was doing. You're okay. All right. So I know, like I said, some of the instructions in the book we're talking about go within a general, and they might have been looking for something a little subtle different or whatever, but what you did for within a revolution by listing out all possible, that's what I'm looking to do. Are there any other of the solves? Yes, sir. Which one? 37. 2 cosine squared?
Yeah.
I know how to do
Dude, I got down to like that.
So right off the bat, rewrite cosine squared as sine squared. Okay. Rewrite cosine squared as sine squared. You get 2 times quantity 1 minus sine squared minus a sine squared, or sine of x minus 1. So we have 2 minus 2 sine of x squared x minus sine of x minus 1 is 0.
Do we need to write out the x's when we solve the equation?
When you're solving equations, you want to keep the x there, because remember, you're trying to figure out what is the angle that has. Now, at this point, you can combine out your like terms, and you wind up with 2 minus 1, so this becomes a positive 1 here. Now, I'm going to multiply everything by -1 and change all of my signs. Is that okay? Yeah. All right. So now I have positive 2 here, plus a sine x, and this is now minus 1 equals 0. If you would like to use the u substitution to help keep things clean, by all means, go for it. If you don't, you just want to say what times what is -2. You add together to get positive 1. That's fine as well. So what times what is -2? You add together to get positive 1. Positive 2, -1. So I'll say it's 2u squared minus u plus 2u minus 1. What I'm doing there, if you remember when we did factoring by grouping and you had alternating signs, remember how it was always easier to put the negative value up front? Michael, you're looking at me like I have got 4 different heads and my hair is on fire. What's wrong?
No, I got -2 sine squared minus sine x plus.
You did it right, Michael. Add everything to the other side, make them all positive, and you'll be where I'm at. I don't know if you might have been writing something down, you might not have heard me. What I did is I multiplied everything by -1, because I can do that. That's like moving it over, and that's all I did. You're just a step behind. You're all right. It's okay.
Where did the 2 minus the sine of x go out in front?
I'm letting you equal that. That's all.
No, like, because when you FOIL out the top part, there's like a 2 minus sine of x. Where did that 2 go?
It was 2 minus 1
Okay, so then you just get plus 1.
plus 1, and then I multiply everything up with a negative.
Okay.
That's where that went. Okay. I had erased it. I didn't write it down the next step. That's all.
Okay.
So I'm letting you do the sine of x. And what did we say? It was 2u plus 1, and then it was u.
That was 2u squared.
2u. So we said our terms were going to be, what times what was -2, add together -1, so it was 2 and -1. So 2u squared minus u plus 2u minus 1. The reason why I put the negative first, just so I don't have to worry about my signs, the SIGNs, it's just cleaner. And then just do your grouping. Take out the u. Take out a positive 1. So now we have sine of x plus 1 is 0, and 2 sine of x minus 1 is 0. So what angle has a sine value of -1?
2 pi over 3 pi over 2.
No, no,
270.
-1 is down here, so it's 3 pi over 2. I'm going to ask these to be on the test. I'm going to say do within the revolution, so you don't have to worry about remembering you're just going to list out all possible.
Oh, so it's not going to be general solution?
No.
Okay.
When I give you something like this is complex enough. Don't get me wrong, you'll have a general
Yeah.
solution problem, but it won't be as tedious as something like this. Okay. So you got 3 pi over 2, and where is sine equal to a half? So,
Pi over 6
And-
pi over 6.
okay. So the way that I'm looking at the test is 12 questions. Okay. Class periods are 48 minutes. That gives you
4 minutes per question.
exactly.
How many minutes per question?
It should. Okay. It also leads you out to believe that if you think about all the types of things we have that would be non-calculator, simplify, verify, what is the angle, what angle has, solve an equation, do a general solution, a revolution. You probably have 2 of everything. There'll be 2 of everything. Yeah, you'll have 2 of equations. Yeah, you have 2 equations that'll be within a revolution, 2 equations that'll be a general solution, 2 verify, 2 simplify, 2
angle.
well, yeah, 2 angle what is, and 2 what is the sine value of like pi over 4, or whatever it might be. Okay, it's all non-calculator.
You get a dozen. I got a coupon for half a dozen
General solution you have to figure out when does how often does it replicate.
Anytime, whenever.
It's so fun.
It'll say general solution, or it'll say between 1 revolution. So you know how I write. Good question. When do you know when you have to do general solution versus a revolution? It'll say solve for the general solution, or it'll say solve within 0 is between theta and 2 pi. That's when you're looking at just your list of all of it. Yes. A general? Yeah, sure. I actually have some here. I'll give you guys.
Well, it's gonna use this study.
This is more beneficial for you guys to have it than me to have it.
I just need to remember these identities.
When I'm talking about a general solution, let's look at number 3. On the about halfway down the page there, it says find the general solution of the equation. Number 3 says find the general solution of 5 cosine of x minus root 3 equals 3 cosine of x. What do you think you need to do to start? No!
Subtract the
Minus-
cosine.
Subtract the 3 cosine.
Subtract the 3 cosine x and add the root 3. We okay with that? Okay, so we have 2 cosine of x equals root 3. Now what?
Square.
So what value of x, what angle has a cosine value of root 3 over 2?
30.
So you place it.
It's 5 over 3.
Your cosine had to be root 3, and 2 is at pi over 6. Okay? What other quadrant is cosine positive?
Third.
Four.
Oh, shoot.
Cosine Cosine's positive going down this direction. So what is that angle as you, 11 pi over 6. So you have two angles, pi over 6 and 11 pi over 6. Are those two angles equidistant apart from one another? No. So therefore, your general solution is going to be what?
Pi over 6 plus 2 pi n.
This is when you tack on your 2 pi n.
Does it matter which one you use?
What do you mean?
If you use, all you have to do, well, all right, okay.
When is the only time you use pi over 2 and
When it's the 45.
when it's the 45s, when it's the pi over 4 plus or minus. That is the only one. Remember, that is the only one that you use pi over 2n when you have pi over 4 as a reference angle in all four quadrants.
She asked what the other one was.
Of what?
The other one that uses pi over 2.
Pi over 4. And then pi over 4.
And then pi over 4.
Only if it's repeated in the four quadrants.
I'm not
Yes, ma'am.
What have pi in the other one?
Yeah. Take a look at this sheet real fast, guys. Take a look at this sheet. And there's a bunch of questions and stuff on here. There's some equations on the back that you have to use, some Pythagorean identities. You want to peruse through some of those. We got about 15 minutes or so. I'm going to answer Emma's question, then I'll keep doing them on the board here, all right?
Number 2 at the top. Okay. 3, 6.
Or we could like write at the time that like these could be like stuck with the and I just kind of like stay with it. Yeah. So you just came and then you're like, okay, I'm like, okay, you could do but I'm not to stay.
Yes, ma'am. What do you want to do? Whatever. No thanks.
Yeah.
For what?
They're
They're free?
Yeah.
It's good.
Can I go on now?
What is it?
I
don't know. Thank you. I'll take free. That's nice. Free is good. Yeah, free is good. $10, you guys are all crooks. All right, let's take a look. Where? We got it.
How do you find the secant of something?
Secant is the inverse of. There you go. That's how you find it.
Like with invert or with like
Yes.
2 exactly the section we just did.
All right, so you have, guys, listen up. Add 7, divide by 7. This is number 2 of the general solution. So secant of x is 1. Secant is the inverse, right?
So would that be r over x?
Right. So now think about it. What angle has a secant value of 1? So what you're asking at, secant is the inverse of cosine. Cosine is x over r, so this is r over x. Where does it have to be? It's got to be at 1, doesn't it? Because when cosine is at 0, it's 1. What's the inverse of 1? 1. So this would have to be at 0, and then what do you do for your general solution of that? Plus 2 pi n. If you wrote 2 pi r, do you think I'm going to yell at you?
Yes.
No.
It could just be a half.
It's a variable.
It's kind of like a half n, half r right there, right? It's in nerd.
But that is obviously in the That's how you do in Spanish. Like if I write an accent, but there's not an accent, I'll be like, there's no accent. It's just like a.
It's a smudge.
Yeah,
There's a smudge in the paper. There's a smudge in the paper. Dear Liza, dear Liza. There's a smudge. Just figure this out. Haven't you figured that out yet? It's like May. You ever figured out that I'm just an idiot sometimes? I don't know. Yeah, it's something. Hey, let's do one of these ones on the back. These are fun.
That story was in the
First one?
roller coaster. So I looked
So this is the first problem on the very back page when you're solving equations. Notice how it says solve for x within 0 is less than or equal to x less than 2 pi. That's what it looks like to solve within a revolution. Which trig function am I going to rewrite?
Sine squared.
Why?
Because it
Can't change cosine.
Very good. Can't change it. You'd like to, but it's stubborn.
wait, where?
You okay with that?
Yeah.
Okay. Distribute. Combine like terms.
Oh, shoot.
Now what am I going to do? I'm going to do all my change all my signs real quick, and then I'll use u substitution. Okay. So I'm going to change all my signs by multiplying out by the negative, and this becomes positive, negative, positive. So I'll rewrite it in terms of u. No, we'll have more. Bless you.
Thank you. Bless you. Bless you.
Oh.
Wait, how did you get that so bad?
No.
All right. Do I have to draw that?
I can tell this is over. More face square.
Hey, I'm gonna test and move to it. One like impressive my face square.
So 4 times 1 is what times what?
Negative 2, negative 2.
Okay. I never heard about it.
Yeah, what times what's 4 you add together to get negative 4, negative 2, negative 2. Yeah, so you have 4x squared minus 2x minus 2x plus 1.
Thought we were using.
Well, it gets too much to
What do I use?
All right. Now, on this one, you just got to be a little bit careful on that second term when you're factoring it out. You got to make sure you factor out the negative 1. Okay. So you take out 2x. You have 2x minus 1. Take out a negative 1, and you get 2x minus 1. We okay with that?
So it's just.
So it's 2x minus 1 repeated.
Why don't you just like 2x minus 1 squared?
It's kind of pointless because you get to still solve for x. I mean, you can if you want. You write it as quantity squared. But all you have to do is set one of them equal to 0. So now you have 2 cosine of x minus 1 is 0. So what angle has a cosine value of 1/2?
Pi over 6
Very good.
and 11.
Perfect. Pi over 6,
Wait,
11 pi over 6.
wouldn't it be 60?
Yeah, I was gonna say.
So it'd be
Oh.
probably 3 and 5.
I shouldn't listen to you.
You probably should.
I agree. What were you saying?
5.
So cosine adjacent, yes, sorry, so it's 6, it's pi over 3 and 5 pi over 3. I was thinking sine too, okay.
Wait, so I did 2 cosine minus 1 squared, and just square root both sides.
Yeah, because you don't need to. Because when you have replicated polynomial terms, you only have to solve for 1 and 0, so it's 10 and 0.
Yeah.
Yes, ma'am.
In the middle.
In the middle.
That's one.
Which one?
First one.
You don't have to write the 5.
Well, I'm interested in
Yeah, you do.
not at
Oh, no. Oh, no, because it was just in one in revolution. If it's in one revolution, you don't have to do the
it has
plus.
like this band right
Okay.
here, and then it's like all the way
Now, in this
down.
case here, when I got into my verify, I'm going to rewrite everything in terms of sines and cosines, and then work for a common denominator. So I have 1 over cosine
Say that, then you add the.
minus, can I say it's sine squared over cosine? Are you okay with that?
Yeah.
Because it's sine over cosine times sine. Do you see that? And now you're basically done because you wind up with the common denominator, 1 minus sine squared over cosine.
That's cosine squared over cosine. Right?
Yeah. Why is it not secant then?
When it-
Because it equals cosine squared.
Yeah.
Did I write down the wrong equal thing?
When it equals secant then?
Equals secant.
Oh, yeah, hold on here. So then you have cosine squared. I was freaking out that I had it written down wrong. So yeah, this, you get cosine, which is 1 over secant. That's
Why
right.
did they put 1 over secant though? That just makes it
What did you put?
1 minus sine squared is the cosine squared, and then cosine is the same thing as 1 over secant.
Wait, why did you just put like cosine?
Because they're jerks.
That was.
Like that messed me up pretty hard. Like I did the whole thing right, and then I looked at the thing, and I was like, wait, did I do something?
All students take calculus from scratch.
No.
That was a trick I was talking about.
Oh, yeah, for your quadrants, yeah. Also, yeah, that makes sense. What's up?
I didn't want to say that.
You have all of them. There's only so many of these that I can come up with. I mean, seriously, there's only so many of these things you can do. They all turn into be kind of the same problem after a while.
So let's do them all. And then we'll test it.
That's funny. Because then on Monday we're gonna start graphing right away. We gotta get graphing done before spring break. Graphing's easy.
Are we gonna make quiz and everything next week?
End of the week. On graphing and trig equations is easier than all this.
Okay.
I'm not gonna lie to you, graphing is much easier. It is very hard pressed for students to screw that up, unless you don't know how to use fractions.
Well, so basically, just doing the graphs, like quiz I wonder how many.
No, we should make that quick
assessments I'm gonna have on Friday before spring break.
I think we did this one already. Oh yeah, we've done this one a couple of times.
Yeah.
Rewrite cosine squared in terms of sine squared, and you're done.
Wait a minute, right?
This is 1 minus sine squared minus sine squared, and you're done.
I just picked
Why?
We got Destiny.
the number 1, like the real number 1.
The very first one.
The cotangent,
No,
Cosine.
number 1.
Yeah.
what angle has a cosine value of -1/2?
I know, I will get one of those wrong. Negative squared.
Now, this is your what angle has a value of. When it's just straight written like this, like it was on your quiz, this is when you have to be careful about your quadrant placing. Remember, cosine comes between here to here. If cosine is negative, it's in the second quadrant. So you're at -1 over 2, so that means you're at a pi over 3 reference. So this is 2 pi over 3, and this would be, what, 60 and 120.
Hey, how do you know
I forgot.
when to just do like the one,
What do you mean?
like, you say like in between, like,
When you go back to your quiz, the 2 quizzes that you guys had, the bottom half were questions like this.
I know, but like. how
Those
do
are the
you know-
ones you guys have, that's when you have to parameter it,
How do you know when to parameter?
when they look like that.
When it's like.
When it's
the
just,
inverse?
when it's just looking like this. When you're solving equations, it's open throughout the full revolution. When you're fully just going for what is the angle, that's this problem. When you go into solving the full-on equation, like it says solve within a general solution or solve within one revolution, that's when you can pick all of the angles. All right. Here, you're just looking for the angle that has. I think you go first.
Do you ever want us to find a negative gradient?
No. Well, I'll do positive. Unless it's a sign value negative. Remember how we did that?
You want us to find
Yes,
a
because then
Will you tell us?
it says it's the same thing as what the quiz was. Question here was this: if it's like the second question, what angle has a sine value of negative root 2 over 2? Sine is negative here, but when you're finding the sine value in a scenario like this, you're between 2 pi to negative 2 pi. So here you'd be at negative pi over 4 at 45.
Okay, so,
Negative 45.
do you only want negative gradients when you're only solving that?
Yes, yes. Just like it would look like on the quiz. The wording is the same. It says evaluate or find the expression, give your answers in both radiant. God bless you. It says
Like
that.
The negative, like 45, is that only if it's in the fourth quadrant?
Yeah.
That's
Now,
only
if
sign
it's-
design.
Yes. And like I said, when it says solve the equation for general solution, if you had wound up like that, you had to find a sine value of that, when you're solving for a general solution, you'd spin around to get to that angle.
Okay.
When it's just evaluate what angle has, when it's just given to you like that, then you got to go to your parameter.
Okay.
All right, that's how it was on the quiz versus the equation. All right. Edric.
Wait, so for the cosine one that we just did, why wasn't it just pi over,
So that's the reference angle. The cosine value, remember the second quadrant, cosine gives you a reference angle that bounces up, your terminal side comes across. Always have.
Oh, okay, so that's number 2. Yeah,
See here, you gotta go. Right, yeah. Because you gotta come up between your fingers here, so it's negative 2, so the cosine is negative over here. So you're right, your reference angle is 45 degrees, but come around to it would have been at 300. Right. You looked at it as a negative angle going down, that's a sine value. That's how it came to the cosine. Because that's what you do on those. That's how you do those. What else went on?
you between it?
What else you want to look at, Eddie? 3 middle pages?
I never learned any of that. I could only do
In this case here, go for, there's no conjugate that really gets you tangent squared and cotangent squared because they don't have anything with Pythagorean identity. So go right for common denominators. Okay? Your numerator becomes sine over cosine. You okay on that? The denominator, you have sine over cosine plus cosine over sine. So your common denominator would be cosine sine. The numerator would be sine squared plus cosine squared. So when you go up and flip it, what does this become? It becomes 1. So you have sine over cosine times the reciprocal here, cosine sine over 1. Sine squared, and I think it asked you to show that it was sine squared. Okay?
It makes so much sense.
But look, remember, when you see something like this and you have an addition in the denominator, go common denominator.
Okay, and
Is
then,
this on your website too, so you can look back at this class, right?
Yeah.
Awesome.
I always do. Yes, ma'am.
so when there's, I really like last time I was trying to find a denominator, you common denominator, and then there's a single term, like a numerator, you do a common.
A lot of times, yes. A lot of times that works. Okay, a lot of times that'll work. Also, if it's a single term, the denominator 2 up top, what are you gonna do? Split it.
Oh, yeah, split.
split them apart.
Sorry, guys.
There's little subtleties.
That's all it
One of them
We've done just about every single style known to man.
Hello,
Yes, you go down, yeah, it's in the down here.
You were having answer the galaxy.
It's the stage between pirates and
Because he splits them up. He splits up the.
So